Good evening again to another online Zoom class, and today we are looking at organic chemistry. But I'm Ing.Momoh Kenie. Just in case you want to add any of the any comment to any of the videos, you can do that via WhatsApp on 076627336. Today we are looking at organic chemistry, which is very key, very important for those that intend to do some science-related courses and engineering, to be precise. If we are looking at that without wasting time, we don't want to waste time. We can just go through the basic things here. This happens to be the most easiest chemistry you can think of. And if you want to define that, you will just say organic chemistry is the study of carbon-containing compound. The study of carbon-containing compound. Carbon-containing compound. The study of carbon-containing compounds. So compounds that contain carbon, when you study them, we call that organic chemistry, with the exception of CO2, CO3, and cyanide salt. That means a salt that contains CN salts. So we now have the right to say organic chemistry is the study of carbon-containing compound that contain carbon, but with the exception of CO2. Have in mind, this compound contains carbon, this contains carbon, there is carbon here. Those are the only compounds when you study them, you don't call that organic chemistry. But any other compound that contains carbon, when you study that, it becomes organic chemistry. But with the exception of this one, these are the exceptions to the definition of organic chemistry. So if they are the exception to the definition of organic chemistry, we now have the right to say organic chemistry is the study of carbon-containing compound with the exception of CO2, CO3, and cyanide salt that contain CN. If that is the case, the other question now that comes will be why carbon? In the definition, why carbon? That means somebody will be interested in that. Why is it that carbon is given preference? We have many elements. We did not say nitrogen containing compound. We didn't say magnesium containing compound. We said carbon containing compound. Why carbon? One of the reasons why carbon is used in the definition of organic chemistry is carbon undergoes a process called catenation. There is a process called catenation. Carbon undergoes that process. What is catenation? Catenation is the ability of the element to combine with other elements to form long chain structure. The ability of a particular element to link or combine with other elements to form long chain structure is catenation. For instance, carbon will link with another carbon to link with another carbon, link with another carbon until a very long chain structure is formed. So carbon has that ability. Number two, carbon has a very large to large extent has increased level of combining with hydrogen, oxygen, and chlorine. That means carbon has got the ability to combine with oxygen, hydrogen, and chlorine. Carbon has that ease. The rate at which it combines it faster. So hence carbon is given preference. The rate at which carbon combines with oxygen, hydrogen, and chlorine is higher. Number three, carbon has the ability to form double and triple bond. That means carbon will link with another carbon in double bond. There are two lines, that is what we call double bond, and they can also combine to form triple bond that way. So if you are asked why carbon is given preference in the study of organic chemistry, you say carbon undergoes catenation. The ease at which carbon combines with oxygen, hydrogen, and chlorine is very high, and carbon has the ability to form double bond and triple bond. That takes us to homologous series. It takes us to homologous series. Homologous series. Now, homologous series will be a series of members in which successive members differ by CH2. If you want to define homologous series, you define homologous series as series of compounds or list of compounds in which successive members differ by CH2. Now, what do we call successive members? If we have something like CH4, C2H6, C3H8, C4, H10, etc., these compounds are successive members. We call this one successive members. And if they are successive members, when you look at them from one carbon to the other, from C1 to C2 is one carbon different. From C2 to C3 is one carbon different. From C3 to C4 is one carbon difference. So in terms of the carbon, you have one carbon difference each. In terms of the hydrogen, you have from 4 to 6 is 2. 6 to 8 also is 2. 8 to 10 is 2. So the hydrogen, they are changing in 2. So we have the right to say homologous series is defined as group of members that differ, successive members differ by CH2. Successive members means you are not going to jump one member, you go to the other. The moment you take this one, you will not jump this and come to this. You take this in that order. That is what we call successive sig members. They differ by CH2. Now let us look at characteristics of homologous series. Characteristics of homologous series. Characteristics of homologous series. The characteristics of homologous series will be 1. Successive members differ by CH2. I have explained that a few minutes ago that members in this particular case, they differ by CH2 from one member to the other. The difference is CH2. Number 2, that when members belong to the same homologous series, they will be prepared by similar methods. Members prepared by similar methods. Members prepared by similar methods. Prepared by similar methods. That means even if you have thousands of them, they are prepared by similar methods. The method you will use to prepare one of the compound or the first one will be similar to the method you use to prepare the 100th member. Now we go to another property that the relative molecular mass differed by 14. Relative molecular mass differed by a difference of carbon and hydrogen, and that will give you a total of 16. Relative molecular mass differed by a molecular mass of 16. How can you determine that? You have CH2. We said the members differ by CH2. If you add this, it's carbon plus 2 times hydrogen. So carbon is 12, the relative molecular mass. Hydrogen is 1. That becomes 12 plus 2 times 1 is 2, and that one is given us 14. So there is a gradual value of 14. The relative molecular mass differed by a value of 14 grams per mole. Now, members belonging to this one again will show a gradual increase in physical properties and melting point. There is a gradual increase in physical properties and melting point. So as a result of that, you have the right to say members, the boiling point of the members differs by CH2, and if that is the case, that will increase the melting point and boiling point. What do we mean by that? If you have CH4, C2H6, C3H8, if this one boils at 10 degrees Celsius, this one will boil at any value greater than 10. Let us say 12 degrees, and this one will be also a value that is greater than 14. That means the more you increase the carbon atom from C1 to C2, there is an increase in carbon. From C2 to C3, there is an increase. So the more you increase the carbon atom, the more you increase the boiling point. Again, the more you increase the carbon atom, the more you increase the melting point. So the melting point and the boiling point will increase as the number of carbon atom increases. We move. If that is the case, it takes us to another set of compound we call hydrocarbon. Hydrocarbon. By definition, hydrocarbons are compounds that contain carbon and hydrogen. Hydrocarbons are compounds that contain carbon and hydrogen only. That means any compound that contains carbon and hydrogen, the molecular formula will be CXHY. They are represented by the relative molecular formula of CXHY. What do we mean by this X and Y? One, the X and the Y value, X and Y, are positive. The value of X and the value of Y, this value down here and this one down, they must always be positive. They will not be negative, and they are always whole numbers. The X and Y are whole numbers. Few minutes ago, I said something like C3H8. When you look at this, the X, this is the X and this is the Y. The X is 3, the Y is 8. So both of them are positive and both of them are whole numbers. That is how we represent hydrocarbons. Now let us look at examples of hydrocarbons. What are the group of compounds we call hydrocarbons? What that means, what are the compounds that contain only carbon and hydrogen? The categories of compounds that contain only carbon and hydrogen are alkane, alkyl, and benzene. These are the categories of compounds that contain only carbon and hydrogen. We have alkane, alkyl, benzene. Those are the compounds that contain only carbon and hydrogen.